So what if you have a problem where instead of given the value of Ka, you're given a pH value? Well, there's a really important thing to note here, which is that when you're given a value of pH, you're also essentially given the concentration of H3O plus at equilibrium. And that's because you know that the concentration of H3O plus is equal to 10 raised to the negative pH. And let's put a big happy star by that because it's very important. For the problem at hand, we are given that we have a solution of nitromethane. Nitromethane is a weak acid. So we can draw its reaction with water like so. It will produce hydronium ion and the conjugate base. The other reaction that is always occurring, of course, is the autoionization of water, which we should write out. We are now ready to assign variables. Nitromethane can be X, H3O plus can be P, CH2NO2 minus can be Y, H3O plus is still P, NOH minus is H for hydroxide. Let's go ahead and set up our inputs, equations, and outputs. The problem tells us that the initial concentration of our nitromethane is 0.45. And we can assume that the initial concentration of Y is 0. Again, we're not going to write down anything for PI or HI because there's just too much uncertainty with the water present. But we do know that Kw is equal to 1.0 times 10 to the minus 14. Note that we're not writing down Ka as a known because that is what we are looking for. Our outputs are X, Y, and be careful with P. We actually know what P is going to be because we were given the pH of the solution. So P is going to be equal to 10 to the negative 5.27, which was the pH. Continuing on, we don't know H, and the thing we're ultimately looking for is the Ka. We're now ready to write equation 1, which will just be the setup for our Ka. So that'll be P times Y divided by X. Equation 2 will be our setup for Kw, as always. That's P times H. Equation 3 is going to have to be a charge balance. You see that we definitely have charged species in solution. And charge balance here is pretty easy. Put your positively charged species on the left. This looks like we just have P. Set that equal to the sum of all the negative charges. So that would be Y plus H. Finally, we are ready for our fourth equation, which is going to have to be a mole balance equation. Remember that in any of these acid-base problems, you do not want to use oxygen or hydrogen to do mole balances with because there's just too much uncertainty with the water that's involved. So it looks like our two options here are either carbon or nitrogen. Let's go ahead and do carbon. So for carbon, it looks like we've got carbon present in our original nitromethane and then in its conjugate base. So we've got Xi plus Yi is equal to X plus Y. So now we're ready to plug into Mathematica. Hooray! And when you plug that into Mathematica, Mathematica will quickly put out a value for Ka, and if you use the correct number of sig figs and make sure that is unitless, then you're all done.